In this video, we're going to look at using a chi-squared test to determine whether there is an association between two variables, i.e. whether the two variables are independent. And this is sometimes known as a contingency table test. So here's a question. There's two stools entering pupils for an exam, and we've got the results of each stool, and we have to use a chi-squared test to determine whether there is a significant difference at the 5% level between the stools. So it's a hypothesis test, so we have to start with our null hypothesis, H1, H0 in this case, is that there is no significant difference between the stools. And that's the same as independence. Of exam result versus stool. And H1 is that there is significant difference between stools. Now, the key thing with the chi-square test is the chi-square test statistic, which is given by the sum of O minus E squared divided by E, where O is the observed values, so that's the ones that we've already got, and E is the expected values, and that's expected values under H0. So if the exam result was independent of the stool, then E is the expected numbers we would have. Now, in order to work out these expected numbers, the first thing we need to do is we need to do some row and column totals in our original table. Let's just add up each row and each column. So the first column adds up to 90, the second one adds up to 20 and 40, and the row totals are that's 80 and 70, and so the overall total is 150. Okay, now to get the expected values, there's sort of a quick formula you can use. It's just using some mathematical probability really, but to get the expected values, we do row total times column total over overall total. So let's do that. So let's have our expecteds up here. So we have stool A and stool B, and we'll have merit, pass, and fail. Now, to get the sort of the stool A merit, we're going to use row total. So the stool A row total, that's 80. We're going to multiply it by the merit column total, so that's 80 times 90, and we're going to divide by the overall total, which is 150. So 80 times 90 over 150 is 48. So that's what goes in here. Let's do stool A pass. We want the row totals. The row total for stool A is 80. The column total for pass is 20, and the overall total is 150. So that gives 80 times 20 over 150 is 10.67. So this is 10.67. And we're going to fill these in the same way. 21.33, 42, 9.33, and 18.67. Okay. And if you've done this correctly, your new table, it should have the same row and column totals as the original. So let's just check it. 48 plus 42 is 90, that's correct. 10.67 plus 9 plus 33 is 20, that's correct. 21 plus 33 plus 18, that's 40, that's correct. And our row totals, 48 plus 10.67 plus 20 does give 80, this does give 70, and overall we still have 150. So this looks sort of sensible. So now we've got our observed values and we've got our expected values. So we need to calculate this test statistics, the sum of the observed minus expected squared over the expected. So let's do that. I'm just trying to just clear some space here. So remember, this was the formula. Chi-squared equals the sum of the O minus E squared divided by E. And so we've got to do this for all 6 sort of squares in our table. So for the first merit stool A, the observed was 51, the expected is 48. So you have to do 51 minus 48 squared divided by the expected, which is 48. Okay, then we have to do the same for the other cells in the table. So you have to do so stool A pass, it's 10 was observed minus 10.67 squared, that's expected, over 10.67, and so on, and so on. And the final term in the bottom right hand corner, we're going to be looking at the these 18.67 here and 21 here. So we have 21 minus 18.67 squared over 18.67. And we just work this big sum out on our calculator and we get 1.0372. So that's my chi-squared test statistic. Now, in order to do the test, we need to compare this with some chi-squared statistical tables. Now, compare with, remember we were looking at the 5% significance level was this test in the question, so we need to compare it with the chi-squared 5% value. Now, if you look at chi-squared statistical tables, they tell you they depend on the number of degrees of freedom of your test. Well, degrees of freedom and I think we use this letter nu. In a contingency table test, it's rows minus 1 multiplied by columns minus 1. So the number of rows in our table, well, there were 2 rows, stool A and stool B, so it's 2 minus 1. And how many columns were there? Well, there were merit, pass, and fail, so it's 3 minus 1. So this is 1 times 2 was 2. So the degrees of freedom for our test is 2. So what we're going to do is we're going to compare with the chi-squared 5% 2 value. So the chi-squared 5% 2 value from our tables, it turns out to be 5.99. So let's just chi-squared 2 value is 5.99. So since our test statistic 1.0372 is less than 5.99, then this is not significant. Therefore, we accept H0 at the 5% level.